Hi, everybody. Welcome back. Okay. Um, we're talking about related samples t-tests. And we talked about slide 24 where we pooled samples. Let's go on to slide 25. Pooled our standard deviation, rather. Okay. Now, second example. Throwing distance in a JV javelin toss from between pre and post season. Okay, and we're talking about the meters that the javelin travels. It looks like we have before the season began, the average distance thrown was 2 meters. After the season, end of the season, the average distance thrown was 4 meters. Okay, the standard deviation before the season began, preseason, was 0.7. Okay, we have a pretest. Okay, we can use that preseason standard deviation, and so we get an effect size of minus 2.86. Okay, so in other words, the distances are 2.86 standard deviations post-season or at the post-test. Okay, 2.86 standard deviations. That's pretty far out there on our bell curve, right? And if you remember, what was our? Let me scroll back. What was our? Yeah, if you remember, usually if you're at 2.86, usually you would exceed your critical value. Well, for seven, for degrees of freedom of 7, we saw 2.365 was the critical value. Okay, so and I'm going to show you. We'll talk a little bit about how this would look in SPSS um, later on in the slides. Okay, so let's talk about confidence intervals. Okay, slide 26. The same like last time. We're using the difference scores. And so for the 95% confidence interval, we need to find the critical value of t by looking up the degrees of freedom in the table. And so for the tardiness program, slide 27, for the tardiness program, we'd use the mean difference, okay? And we have our standard deviation, our degrees of freedom was 7, right? So we plug everything in. I'm at slide 28. And we find that t-value given those degrees of freedom. And we plug in our standard deviation. We take the square root of our sample size, and we know what our difference is. Okay, and so then we have our confidence intervals, our difference, plus or minus that t statistic that we got from the table times the standard deviation divided by the square root of n. Okay, and what we get is the confidence interval on the tardiness study is there's a range of where we think a mean might be, and that's from minus 277.6 minutes to plus 506.8 minutes. So either the distance could be, negative if you're doing post-test minus pre-test. Negative would mean that they did go down if you do post-test minus t-test to pre-test to calculate the difference. Post-test minus Negative would mean they did not go down, that the pretest was higher than the post-test, okay? And positive would mean if you do post-test minus pretest, positive would mean that it did go down the number of it would mean that it went up. Oh man, usually we're looking at for gains, and in that study we're looking for a decline. So I'm saying it all backwards. But anyway, the main point is that somewhere in the middle of that confidence interval is 0. So you do not know that your program had any effect, either positive or negative, because within that width of minus 278 about to positive 507 about is 0. Okay. Slide 29. Yeah, you're not likely to get a difference less than negative 278, right? We're 95% confident that the population mean would fall between 270, this minus 278 is positive 507, okay? The 0 is inside of our confidence interval, so that this sample has a good chance of coming from a population where the mean difference is 0. So we fail to reject our null, which is the same decision as before, but just another way of getting at it. Slide 30. So let's talk about the javelin throwing, right? So pre to post season. We had a difference of 2 meters, and yes, and pre was less than post, and our standard deviation of this difference was 0.94, and our degrees of freedom, and it looks like we have 5 athletes there. So n minus 1 is 4. Our confidence interval, again, it's the same critical T. Actually, no, it's different because it's for 4 degrees of freedom. Before we were looking at 7 degrees of freedom. The critical T is 2.78. We take our difference, our mean difference, and we're going plus or minus T times the standard deviation divided by the square root of n. Okay, and so you plug in those values, right? And you get negative 0.83, somewhere between negative 0.83 and negative 3.17. So there's no 0 between two negative numbers, right? 0 is going to be on the other side of negative 0.83, right? So since 0 is not within our confidence interval, we know that we can infer that there was a decrease between preseason and postseason, or there would be in a population of similar athletes. We would expect there to be a decrease in the distance. There would be a if you did postseason, preseason minus postseason, yeah, you would expect that they were throwing in the preseason they were throwing the javelins less far than they were in the post season. Okay, so their preseason distances we would expect in a population of similar javelin athletes that they would have improved. Okay, so based on that, and you can see that from the confidence interval. All right, we reject the null. We had a really large effect size, so it makes sense that we would reject the null in this case. All right. So now this test, very easy to do in SPSS. Okay, a paired samples t-test is what it's called in SPSS. So you would click on Analyze in the menu bar. Then you'd be comparing samples, or yeah, I would look under each. I don't think it says comparing samples. It says something else. But you're doing the paired samples t-test. I don't know. This might, yeah. Look under that, under analyze, and see what kind of looks like some tests of means is what you're looking for. Okay, so this on slide 34, you see the output that you would get if you used the Javelin data. So you can try it. And if you look, okay, so it shows you some just basic statistics, descriptive statistics for your two samples, your mean, your number of participants, and your standard deviation, as well as the standard error of the mean. Um, um, in that first box. The next box shows you the correlation, which again we're going to learn about a little bit later on. And then finally we get to the paired samples test. And here it's if you see it shows it did preseason minus postseason. It found a mean difference of -2, which is what we expected. It shows the standard deviation of the distance, the standard error of that distance, and then the confidence interval, which we just talked about. And then it shows the t-statistic, the degrees of freedom used for that t-statistic, and the significance. Okay, and you would report it, you would, say your concluding sentence. We conclude that in the postseason, athletes will throw a javelin further than in the preseason. And comma, T, or in parentheses, you can put T, parentheses 4 for your degrees of freedom, minus, and then your T statistic equals minus 4.781, comma, italicize P equal to 0.009. And you can either put it, comma, and just finish your sentence like that. I do see it in parentheses a lot. Okay, it's up to you. Now, again, P is less than 0.05. So we reject the null hypothesis. Yeah, the difference between preseason and postseason is not 0. And now we have this specific t-value. Before we were just comparing it to a critical value that was on our table. But now with SPSS, we have the specific t-value. We see it's negative since we put the preseason first. Since preseason was first in our data set, it did pre minus post, or when we did the command, the little app within the app, we put preseason in first, so it did pre minus post. This resulted in a negative average difference, so we can say that the postseason throws were longer than preseason throws. We could also look at the means. So power for repeated sample t-test is the same as what we looked at last time. Okay, our delta equals D for effect size, not for difference. Delta equals our effect size times the square root of n. Okay, but effect size is just a little bit different. For our related samples test, our effect size is calculated the one mean minus the second mean divided by the standard deviation of the difference. Okay, so and that was in your SPSS output, right? So output. So if you go back to slide 34, in that last box where it says paired samples test, you see preseason minus postseason, mean, and then the standard deviation of the difference. Okay, so that's where that's at. Now let's look at the power for the tardiness program. This is slide 37. We're using these sample values as estimates of the population. We calculated the standard deviation of the difference before. We know the average after the program and the average before the program. And we know that so we can calculate our effect size as 0.244. Okay. how come that's a different effect size than what we got before? Didn't we get 0.3 something? Effect size. Nope, 0.23. Yeah. On slide 24, it says 0.23. Okay. So was our effect size. Okay. So this is similar. Where am I? Similar. Okay. 0.244 times the square root of 8 equals 0.69. So that's our delta. We look up that delta on table E5. It's below the first value, right? Because it's below the first value with a power of point. So we don't have enough students to have a reasonable type 2 error rate, okay? So it's likely that our failure to reject the null is actually a type 2 error. It's a lack of power. Um, so how many students would we need for a power of 0.8? Okay. So let's say it's a small effect. It seems like it would definitely be a small effect. A lot of factors may go into students' tardiness rates. We look at for a power of 0.8, we still need a delta of 2.8, and we need an N of 196 students. Okay, so you'd need at least 196 students to detect a small change in minutes tardy, if you wanted to have a power level of 0.8. Okay, so that's a lot. For a tardiness study, you need a whole lot more than 8 students. Okay, and that's the end of this lesson. Again, congratulations on making it to repeated samples t-test. You are now using the same tool that is used in journal articles currently. So you made it. Congratulations and happy statisticking.